Hello everyone, welcome back to another geostatistics lecture video. And in this lecture video, I want to go through an actual example of our lagged mean calculation. So what I've got is our 9 polygon grid here from our previous examples, along with the corresponding Rooks case weights matrix. And then over here, I have just a little table to help us keep track of everything. And so what I want to do is I want to go through an example of calculating the lagged mean. So again, we're talking about lagged mean. And so just to recap that equation, right, the lagged mean of the ith polygon is equal to the sum of its neighbors divided by the total number of neighbors. And that's this symbol here. Right, so we're literally taking the average of all of the neighbors based on the weights matrix that we calculated. So let's take a look at 1. Right, so 1 has 3 neighbors. It has itself, 4, and 2. So that's going to be 33 plus 35 plus 34. And again, I'm looking at the weights matrix, and I see that 1 is adjacent to 1, 2, and 4. So I'm going down here and I'm pulling out the values of 1, 2, and 4. That's where these are coming from. And then we're going to divide that by the total number of neighbors, which in this case is 3, which is going to give us a value of 102 over 3, which is going to be 34. So we can put a value of 34 right there. Okay, so that's the equation. That's applying it for the first polygon. Let's go ahead and do 2. Now I'm just going to look now rather than using the weights matrix. But again, this is where the weights matrix comes from in terms of computer. For me, it's a little bit easier just to look and see that we would take 33, 35, 32, and 29. And again, I'm pulling in the neighbors. So 1, 3, and 5, and then obviously itself. And dividing by 4. So that's going to be 129 divided by 4, which is going to be approximately 32.25. We can go ahead and throw that up here as well. All right, so let's do a couple more just to make sure that you understand how this works. Let's do 5. All right, so we're going to skip down. We're going to go to 5. So 5 would have 29 plus 35 plus 34 plus 28 plus 27. Right, divided by, well, how many neighbors are there? There's a total of 5. Right, so that's going to be equal to 153. Right, that's the sum of this top row, divided by 5. And if you do the math on that, you get 30.6, which we can then add to our table over here. Let's do one more. Let's do 9. Let's jump all the way down to 9. Give myself a little bit of space here. Jump all the way down to 9. All right, so 9 has 25, which is the value of itself, plus its neighbor 6, which is 28, plus its neighbor 8, which is 27. And there are 3 neighbors in total. So that's going to be equal to 80 divided by 3, which is going to be approximately 26.7. So we can go up here, and we can add 26.7 to the list. Now, I would encourage you to pause the video. I would encourage you to go and maybe try on your own to calculate the the ones that we haven't, so 3, 4, 6, 7, and 8. And in the next video, we're going to talk about what we do with these and how we sort of interpret the results. So if any of this was unclear, I strongly encourage you to go back, rewatch the video, maybe rewatch the previous conceptual video. And as always, please reach out. Thank you.